You want to start by creating a sphere, particularly a high poly one, so that you don't see edges in your renders. You then want to apply an AI standard surface to the sphere, setting the base color value to black, setting the base roughness value all the way up, setting the specular value to 0, and the specular roughness value all the way up. This will completely eliminate any depth whatsoever, no matter what light you're shining on it, no matter what angle you're rendering from, perfectly simulating a black hole. Next, you need to duplicate the sphere that you've just worked with, make it slightly larger, and then open Hypershade. Once you have Hypershade open, create an AI standard surface, an AI facing ratio, and an AI range node. These three nodes, once connected, will simulate the way a black hole captures and morphs light. We'll start by editing the parameters of the AI standard surface. You want to set the base weight to 0, the base roughness to 0, and the specular roughness to 0. Lastly, just setting the transmission to 1. The next node we'll be editing is the AI range node. You want to set the output minimum to 1 and set the output maximum to 100,000. It's a large number, but it's what it needs to be set at. The last node we're editing is the AI facing ratio node. Set the bias to 0.1 and then just set the gain to 0.01. Now to actually get all of this working, you want to connect the three nodes that we've created. Start by connecting the AI facing ratio's out value to the AI range input R. The connection input R is inside of the input dropdown in the AI range node. Then connecting the AI range out color R to the AI standard surface specular IOR. Both of these things, just like with the AI range node, you will need dropdowns for. Out color R is in the out color dropdown of the AI range node, and specular IOR is really far down in the dropdown for the entirety of the AI standard surface node. The last steps for the black hole itself are to click on the sphere, go to Arnold, then visibility, and uncheck the diffuse transmission as well as the specular transmission. Once you've done that, you want to click on the sphere again if you clicked off of it, go to render stats, and then check the opposite box. Now you should have a fully functioning simulation of a black hole within Maya. Go ahead and take a render to make sure that it works. The best way to know quickly whether or not the lighting is working correctly is to use an HDRI within an AI Skydome. The absolute last thing we're going to do now is kind of optional depending on how far you want to take it, but we're going to make an accretion disk for the black hole. That process is a lot more simple, and there's a lot more approaches that you can take to this than you could with the last part. What I did specifically was I went to generate, get brush, and then I scrolled down to the galactic brush, and I used one of those with the density being extremely high to create a ring around the black hole. Once I had a ring, I just set an emission value of 5 and made it orange. Then it shined and reacted to the light just like how it would with a real black hole. The way it looks wrapping around the black hole is why I specified that you can take really any approach to this, whatever you prefer, because the shape and the look of the accretion disk is going to still look the same along the top of the black hole and the bottom of the black hole, no matter how you approach it. That's all I've got. Please let me know if you have any questions or feedback, anything along those lines at all. I don't do a lot of tutorials, so this is all kind of new to me. Thank you guys in advance if you do, and thanks for watching.